Let's apply de Moivres theorem to prove that cos 4a equal to 8 cos to the power 4a minus 8 cos square a plus 1. So we want to apply de Moivres theorem to prove this identity, this trigonometric identity. For that purpose, we should write what is de Moivres theorem. By de Moivres theorem, we have cos theta plus I sin theta whole thing to the power n equal to cos n theta plus I sin n theta. So we know that this is the formula by de Moivres theorem. However, here we have n theta, and what we want to prove is cos 4a or cos 4 theta. For that purpose, what we should do is we should take n equal to 4. We should take n equal to 4. That n, if we put it here, we will get the required amount, required expression by after simplification. Let's take n equal to 4. Take n equal to 4, comma, we have cos theta plus I sin theta whole thing to the power 4 equal to cos 4 theta plus I sin 4 theta. Now, right hand side is quite a simple expression, cos 4 theta plus I sin 4 theta. We just need cos 4a or cos 4 theta. That's the real part of the right hand side. What about left hand side? Let's compute the real part of the left hand side. So what I want now is cos theta plus I sin theta to the power 4. But cos theta plus I sin theta to the power 4. If you know binomial theorem, you can apply binomial theorem, but assuming you do not know binomial theorem, let's do it something like this: cos theta plus I sin theta square, again square. That's your cos theta plus I sin theta to the power 4. Now we have cos theta plus I sin theta whole square, that is your a plus b whole thing square. A equal to cos theta, b equal to I sin theta. We know the formula: a plus b whole thing square is a square plus 2ab plus b square, and a is cos theta, so cos square theta. Cos theta whole thing square is nothing but cos square theta. A square plus 2ab plus 2 into cos theta into I sin theta. A square plus 2ab plus b square plus b square. I square is minus 1, so we need to write plus. Let's write minus. And sin theta whole thing square is sin square theta. Wow. So we have applied the formula a plus b whole thing square equal to a square plus 2ab plus b square. Since I square is minus 1, we got minus 1 here. Next step, what we will do is we'll just write real part and real part together and imaginary part together. So we have cos square theta minus sin square theta, that's the real part of the complex number, plus I into 2 sin theta cos theta. Let's write it that way: 2 sin theta into cos theta. Everything is square as it is. Now once again we have a plus b whole square, a plus b whole square. We can apply that formula, a plus b whole square equal to a square plus 2ab plus b square. So that is equal to cos square theta minus sine square theta a square. That is your a, so a square plus 2ab plus 2 into a is your cos square theta minus sine square theta into b. B is that whole expression into 2i into sine theta into cos theta. So we have a plus b whole thing square to be a square plus 2 into a into b plus b square. A square plus 2ab plus b square. What is b here? B is 2i sine theta cos theta plus b square. Let's do it square. Now, if we look at the actual formula that we want to derive, we have cos 4a equal to 8 cos to the power 4a minus 8 cos square a. And what we can see is that we don't have anything like sine in this expression. Everything is in terms of cos, cos, cos. So let's do the same thing here. Let's try to write the quantity. Before writing that, we can compare real part and imaginary part. We should simplify and compare it. Cos square, we have got expression cos square theta minus sine square theta whole thing square. Let's simplify it. Here I square equal to minus 1. So let's write that minus 1. And 2 square is 4. So we have minus 4. I square is minus 1. Sine theta whole square is sine square theta. Cos theta whole square is cos square theta. And then 2 into 2 is 4. The imaginary part consists of plus 4. 2 into 2 is 4. Plus 4 into cos square theta minus sine square theta cos square theta minus sine square theta into sine theta into cos theta. Sine theta into cos theta. Into I. That's our imaginary part, and this big expression is our real part, and this big expression is our imaginary part. On the right hand side, what do we have on the left hand side? Or is it right hand side or left hand side? This is our left hand side actually. This is equal to cos 4 theta plus I sine 4 theta. So the expression is equal to, let's write on the next line. This big expression that we have obtained is your left hand side, and your right hand side is cos 4 theta plus I sine 4 theta. So we compare real part and real part. Oh, we compare real part and real part to get the expression. Of course, if we compare imaginary part and imaginary part, we get something more. Let's compare real part and real part to get the required expression. Cos 4 theta equal to cos square theta. Cos 4 theta equal to cos square theta minus sine square theta whole thing square. That's one part of the real part, minus 4 sine square theta into cos square theta. As I have said earlier, there isn't anything like sine square theta in our expression that we need to derive. So let's write sine square as 1 minus cos square. So this is cos square theta minus sine square is 1 minus cos square. So minus 1 plus cos square theta whole thing square minus 4 into sine square can be written as 1 minus cos square theta into cos square theta. That's equal to 2 cos square theta 2 cos square theta minus 1 whole thing square minus 4 cos square theta plus 4 cos to the power 4 theta. Again, we can apply a plus b whole thing square, a plus b whole thing square, where a is 2 cos square theta and b is minus 1, to have 4 cos to the power 4 theta, that is your a square, plus b square minus 1 whole square is 1, plus 2ab. So minus 2 cos square theta into 1. So that's the expansion of 2 cos square theta minus 1 whole thing square, a square plus b square plus 2ab. Since we have minus 1 here, let's write that minus 1 in the front to have minus 2ab. Minus, I forgot something, minus 2a into b. So a is 2 cos square theta. Yeah, now we are correct. Minus 4 cos square theta plus 4 cos to the power 4 theta. And if we simplify, we have the result. This is equal to 8 cos to the power 4 theta minus 8 cos square theta plus 1. Okay, as an added advantage of the Moivres theorem, let's compare of course we have derived what we need to derive. Let's compare the imaginary part as well. If we compare imaginary part, then we'll get expression for sine 4 theta as well. So we have imaginary part here and here. So sine 4 theta equal to, if we compare imaginary part, then we have sine 4 theta equal to 4 cos square theta minus sine square theta into sine theta cos theta. That's the imaginary part. Sine 4 theta equal to 4 times cos square theta minus sine square theta into sine theta cos theta. Did we copy correctly? Let's see. Imaginary part equal to 4 times cos square theta minus sine square theta, whole thing into sine theta into cos theta. That's the imaginary part. And imaginary part, if we compare the imaginary part, then we will be able to compute sine 4 theta. 4 times cos square theta minus sine square theta, whole thing into sine theta into cos theta. So that is equal to 4 into we can multiply by sine theta cos theta, so we have 4 sine theta into cos cube theta minus 4 uh, sine cube theta into cos theta, sine cube theta into cos theta. Wow, we have an expression for sine 4a as well that is not given, that was not asked. And so we have sine 4a equal to sine 4a equal to 4 sine a into cos cube a, 4 sine a into cos cube a minus 4 sine cube a into cos a. Into cos a. Alright, so we have not just computed cos 4 theta, but we have also determined formula for sine 4 theta or sine 4a as well.